Last time we already learned 5 axioms and 5 theorems with one variable in order to simplify Boolean equation. And this time we will learn another 7 theorems that involve several of the input variables. So again, a theorem is proven using either truth table, axioms, or other proof theorems. And still we'll learn the theorem itself. It's draw a form by converting n into or whenever you see 0, you convert into 1, 1 into 0, then we'll have its draw form. We have the name of the theorem and also why is it helpful. However, instead of proving them or showing the circuit of why is it helpful, we'll just say a general phrase over here is together they help to simplify the Boolean equations because it's going to be more complicated in using, and we'll give some examples because they're more complicated after this. So we have the theorem T6 here is B and C is the same as C and B, or the order is the operand is not important, or B or C is the same as C or B. And this one is called commutativity. And theorem T7 is B and C first, then you end with D is the same as C and D first, then you end it with B. Similar, we have B or C first, then OR with D is the same with C or D first, then you OR it with B. So this one is called associativity. Then the G8 is gonna be B and with C, or with B and with D is the same as B, then N with C and D. Okay, so this one is we simply factor out the B and we'll have C or D remain. So its dual form is gonna be B or C first, then B or D, then you product them or you add them together is the same as B or C and D. Okay? And this one is called distributivity. Now the next one is T9. You're gonna have B and B or C is the same as B. And this one is helpful because it's gonna replace a whole set of two logic etude with B itself. Okay, and its dual form is written as B or B and C is the same as B. Okay? Then this one is called covering. Okay? The next one over here is you'll have T10. So you'll have B and C, or with B and not C is the same as B. And this one is very important. You can combine, set up 1 operator, 2 operator, 3 operators in B only. And especially if you see this, it's similar to the form of sum of products. And that we'll learn if you use Boolean equation in form of sum of products. Normally, this form appears a lot. And you will see if you see C and not C, you can cancel 1. Okay, and just bring C only. Again, if you remember the sum of product form, this one will come in handy. Okay, and for us to minimize the Boolean equation. Similarly, you'll have the form B or C, and with B or not C is the same as B. And this one again is very important if you use the way product of sum. You know, see, this one is actually the product of sum. If you use product of sum to transform the truth table to Boolean equation, this one is very useful in order to cancel the operators and simplified it, become only B only. And that's why this one is called combining, and I was saying that's why that I write this one as bold. Okay, so this one I emphasize it at bold because it's very important. Again, this one is in form sum of products way of transforming truth table into a Boolean equation because it has the form of sum products. So using this will help you to simplify it. And this one is dual form, is it's products of sum. So you'll see this one is a products of the sums of the Boolean equation when you convert from truth table to this form. So it is very helpful. Okay. Now the next one is 11. Theorem 11 is if you do B and C or with not B and C or with C and D. So this one is also, you'll see it happens in the form of the, what is that? Sum of products, okay? And it can be simplified this way. You still have sum of products there, but this one is simpler than the previous one. And you have similar one over here that is about B or C and so on and so forth. And this one is in form of product of sum. Okay, it's gonna help to simplify that too here. Okay, and this one is called consensus. Then the last theorem is T12 over here. We'll have which is you have B0 and with B1 and with B2 so on and so forth. Then you negate all of them. Okay, you negate the and, not negate the individual element, but you negate the whole result of the whole and sets there. Okay, it's the same as negate of each one of them, and whenever you see the and, you convert into the or, you see the and, you convert into the or. But this time is the negation of individual element, and this one is very important. So it is negation of the whole set, or the and it's become the negation of each individual, but you also need to convert the and into the or. Okay, and its plural form is similar. You want to have the negation of all the or together. Okay, but that one is the negation of the output of the or. Okay, so the negation of B0 or B1 or B2. Okay, negation over here is the same as negation of the individual element, and also you change the or into the and. Okay, and this one is another very commonly used operator. Okay, and this one is called the De Morgan theorems. So in the next one, we're going to learn how to use the ASIOM first 12 theorems that we have learned so far in some examples. Okay. Oh, and before that, to prove all this, we can use other ASIOMs, or you can combine some proof one to prove others. But again, the simplest one probably is to use truth table. Okay, you just provide the truth table. Let's say just truth table for B and C. What is the left side going to produce? For C and B, what is the right side is going to produce? If they have the same truth table, then they are the same. Okay, so this one, let's say most of them will have 3 variables, so they're gonna have maximum about 8 rows inside your truth table. So it's not that difficult to prove. So it's easy to improve them. Okay.